Now let's talk about vertical stretching or compressing. The graph of y is equal to a times f of x will be a vertical stretch on the library function y is equal to f of x. This vertical stretch is obtained by taking each y coordinate and multiplying by the constant a. The x coordinates will remain unchanged. So each point on my graph becomes x a times y, and a vertical stretch away from the axis will occur if a is bigger than 1. Because if I multiply by a number larger than 1, then the size of my y value will increase. A vertical compression towards the x-axis will occur if a is between 0 and 1. This will take my y coordinate and make it smaller, moving it closer towards the x-axis. We will only consider the case where a is greater than 0. If a is less than 0, we will assume that what we have is a vertical stretch or compression in addition to a vertical reflection. So we'll first take the absolute value of a and stretch or compress our graph, and then we'll reflect the graph over the x-axis as we learned to do when we talked about reflections. Let's take a look at some examples. In our first example, we have y is equal to 2 times the absolute value of x. We notice that the 2 is multiplied by the library function absolute value of x. So we start with y is equal to absolute value of x, and we know how to graph it. Then, since we have a 2 multiplied by absolute value of x, we recognize that this is a vertical stretch. Since the value of the constant that's multiplied is 2, and that's greater than 1, it will result in a stretch away from the x-axis. What will happen is that each of our y coordinates will be multiplied by 2, resulting in a stretch away from the x-axis. So we can see our graph gets stretched, and each of those y coordinates has been multiplied by 2. Now, one thing to pay attention to is the fact that the point at the origin does not change. That's because it has a y coordinate of 0, and 0 times 2 is still 0. So as we stretch away from the x-axis, it's almost like the vertex of our absolute value function is pinned because it's located at the origin, and the rest of the graph is just shifted up. Let's look at another example. In this case, we have y is equal to 1/2 the absolute value of x. So again, we have the same library function as in the previous example. Y is equal to the absolute value of x, and we know how to graph that. We see that we're multiplying outside of the library function times 1/2. Since 1/2 is between 0 and 1, this is going to result in a vertical compression of 1/2. So we're actually going to compress the graph, and it's going to get compressed towards the x-axis and flatten out. Each of our y coordinates was multiplied by 1/2. Again, our point at the origin doesn't change because 0 times 1/2 is just 0, but the y coordinates on all of our other points get multiplied by 1/2. So this is the graph of y is equal to 1/2 the absolute value of x.